I hope you had an enjoyable morning so far, some interesting presentations. Until a couple of years ago, cars talking to one another would probably have been science fiction, right? Things being produced in a factory talking to the machines on the shop floor would have been science fiction. On the other side, you probably have seen some of these things in movies, right? You remember the talking car in Knight Rider? You remember actually intelligent machine beings and Matrix Reloaded? That was obviously fiction. Now, interestingly enough, reality is catching up with fiction at this point in time, mainly via the Internet of Things and Services. And what is interesting about that, that actually can provide some real life benefits, whether it's for economy or whether it's for society as a whole. Cars talking to one another can significantly improve safety on the roads. I will give you some examples of all of these kind of things later. Things being intelligently routed through factories will make manufacturing a lot more flexible and a lot more productive and therewith more affordable ultimately. That is what drives us at Bosch actually, these kind of examples. And it is quite interesting that some over 40 years ago, Charles Eames, which I think many of you might know, said eventually everything connects, people, ideas, objects. I guess quite a number of you might like the chairs he designed. They have emotionally connected with the audience. Now we are taking this whole thing one step further. And we call this the connected world. Ultimately, we believe, as part of the megatrends you see here on the chart, that we will have lots of different devices which will talk to one another and which will make these kind of scenarios I just mentioned before possible. They all will have an impact on the other trends here also. If we think about urbanization, the number of people living in cities actually will increase from 3.2 billion to about 6.3 billion over the next years. By 2050, actually, 2/3 of the human population will live in cities. We'll come back to that point later. It's very important. I'll show you some real-life examples of what can be done in order to import that connected world, to expose that also in cities, similar to what the Mayor of Santander discussed with you before already. As many of you have seen this morning already, Jim, Paul, everybody has shown some charts in regard to the connectivity which already exists. That's the upper part here. In a couple of years, 75% of the human population will be connected in one way or the other to the internet. Now, a colleague of ours talked to a United Nations officer a couple of months ago. And he actually said in crisis areas these days, when a lot of refugees are actually coming together because of necessity and emergencies, actually very often they're not asking for food or water anymore. They're actually starting to ask for internet connectivity because they want to be in touch with their neighbors. They want to see how their neighbors actually did, where they are they still actually amongst us. They want to talk to their relatives actually, etc. So quite an interesting change in terms of needs. Now, that is still the human component of the internet, which drove the last 20 years or so, right? Connecting people together, connecting enterprises. The next step is now that we have all these devices which are getting connected, and there are lots of different numbers around actually, right? That is just one number which we see actually developing. And through that connectivity, things will start to become smart. Not the connectivity itself, but the functions we can establish based on this actually. We'll get smart things. And if we look at this chart, which is from Professor Fleischer, Professor Fleisch from the University of St. Gallen, which we are working very closely with in regard to the IoT. He actually defines the IoT as a thing which we traditionally know. That might be a washing machine, it might be a phone or anything else, combined with the IT, hardware or software. And as a result, we'll get not only the thing-based function, which is what you could call the primary function, right? You make a phone call with a phone. You look through your glasses. You drive with a car from A to B. These are primary functions, right? And now we'll get, through the addition of hardware and software, we get an IT-based service, a secondary function, suddenly on top of that. That secondary function might not be local anymore. It might actually involve different business models. Take the example of the car, driving from A to B. If something happens along the way, suddenly a sensor detects that there is an accident. The sensor actually notifies another device in the car, which automatically transmits in an emergency call to the authorities. Ambulance is being dispatched, etc., etc. That actually is becoming mandatory in some countries in Europe by the 1st of January next year. That will happen. That's a real-life application of IoT already. So through these things becoming smart, we will see a lot of new functionalities being enabled, which will provide lots of new opportunities for businesses as well as society. Now, one prerequisite is obviously that things need to be IP enabled. You probably know Bosch more as a producer of things. Who knows Bosch actually has a Bosch device in their homes? Quite a number of people, actually. So you might have a washing machine, you might have a power tool. You certainly will have, if you drive, lots of devices in your car which are from Bosch. We are, at the moment, enabling more and more of these devices to be IP enabled. In addition, obviously, to some of the other factors here on the chart, wireless capability, low power consumption, ultimately, and that is also something which is already happening in the labs, where these devices are grabbing energy from the environment and actually are utilizing that instead of living off batteries, actually, which have a finite lifespan. So that is one of the enablers which is currently being worked on. Another one, more importantly, is actually when we look at these kind of applications, we need to always keep the user in mind. And as we are getting into new areas here, the question will always be, what is ultimately the need of the customer and what is the value and how can we create additional value for them? Now, very often, unfortunately, users don't necessarily know that, right? But if they get these kind of new functionalities, suddenly it becomes indispensable. Just think about iTunes, think about PayPal, think about WhatsApp. I think we all probably here in this room are using these without necessarily having expressed years ago that this is something we want, right? Nevertheless, that has become now part of our life. And similarly to what has been done in this area, we'll also see new applications, new functionalities being created that will kind of seep into our daily lives. Importantly, in this context, this will often require new business models. And I think Jim has mentioned that before, where actually these new thing-based functions will suddenly drive changes in the way how we consume certain things. Also in this context, it's important to note that no company on its own, neither Bosch nor anybody else actually, will be able to start to initiate these kind of new functionalities and to keep these going over an extended period of time. It requires a lot of different partners, people, companies, etc., to come together to make this happen. And I think we'll later on discuss this a little bit more in the panel discussion also. This is one of the critical success factors we see in order to make the Internet of Things and Services happen. Another aspect is actually user experience. You can imagine by billions of devices becoming connected, the complexity of the environment is going to increase significantly. Nevertheless, studies in the US, on which we have developed a technology acceptance model have clearly shown that for users to accept these new functionalities, two things are vital. The use or utility of the device, of the service, and the simplicity on the other side. These two things are critical for anything to succeed. As a result, we need to always keep in mind these kind of factors here. How can we actually add value to what users want from their devices, and how can we keep it as simple as possible? We are showing downstairs some applications which have been developed in the city of Monaco. I'll come back to that later, where we have specifically applied these principles also to make the app, to make the access to these kind of services as straightforward, as joyful to use as possible. As a whole, in order to summarize that, we call this connected world solutions. It contains 4 different aspects which need to come together. The user, as we have just discussed. We have on the right side the enterprise, the service provider, which is enabling the service, which is providing the service, which is running the business model. We then have the things which on the lower left side need to be connected into this whole environment, as well as on the other side also the partner ecosystem. As said, many partners need to come together. Let me give you some examples. And examples mainly from these 5 areas. These are the areas which we believe the Internet of Things and Service will have the most impact. On one side, industry or manufacturing. We defined some years ago, actually, interesting enough, together with the former CEO of SAP, Mr. Kagemann, the so-called Industry 4.0 concept. And I think it was briefly mentioned before. That's the next phase of manufacturing, cyber-connected systems, where machines are talking to machines on the shop floor, where things are actually talking to the machines, and where we ultimately will have fully automated factories which will produce things more or less on their own. And that is already happening. For the ones who maybe noticed, a couple of weeks ago, BMW put out a press release to announce some of these pilots already in real life, actually. Then we have mobility or transportation. Mobility, in our context, how we call it, is normally transportation, actually, energy, smart home, and smart city. Brief examples from there. Connected world solutions for mobility obviously include the driver. It includes a service provider. That might be a leasing company, an insurance company. We heard some scary examples there before about what might happen to car insurance, and they will happen because they happen already. On the other side, it will involve the car. So not necessarily only one single sensor, right? The car in this regard is the asset. It's a complete system with hundreds or maybe thousands of sensors in there, which ultimately then provide the information and the feedback loops in order to provide additional services. And then we have, obviously, the partner ecosystem, whether these are workshops or anything else, actually. One example in real life, not a simulation, a real life example, which is running here in Singapore since 2011. This is a connected infrastructure. Don't worry about what it really is. It's in this regard a charging station for connected cars, about 120 charging spots all over Singapore. These are intelligent things. These are smart things because in addition to all the electrical functions they have in them, they also have a software stack running on them. They're connected then afterwards into an IoT platform in the back end, which basically then looks at all the events, not at all the information, at all the events which are being generated in the charging station, because the charging station itself already filters and analyzes the data coming from the smart meter, coming from the various components within that charging station, and then actually crystallizes out of that relevant events, which are then being transmitted over the air to the IoT platform, actually, right? And that might then initiate an authentication procedure. It might initiate actually the release of the plug so that you can actually put it in your car and charge it. it will actually initialize then also the billing and also the presentation of the charging events in the respective user interfaces, whether it's the portal or the mobile phone or anything like that, right? That is running since middle of 2011 here, and it's just one example of a connected infrastructure. It could be anything. It could be the barriers actually in the car park. It could be lifts. It could be anything like that, right? Just one example actually, which is providing for a new way, for a new approach actually to running these kind of assets. Two other examples here, also real life already. Car-to-car communication. Wouldn't it be great if your car would tell you that around the next corner there is potentially a pothole in the street, please avoid it, because otherwise you might have an accident. Or in Europe, there's ice on the street, more importantly even, right? Or fog or something like that. That information comes from the car driving in front of you. That is already happening. There's a pilot running where we are doing exactly that around the city of Frankfurt, my hometown, and where already cars are communicating with one another independently and are actually advancing information which might prevent accidents to happen, right? Another example on the lower left side is where we take information out of the cars, similar to what Paul had described, and where that is being used, for example, by LeasePlan. LeasePlan is one of the largest leasing operators in the world. They're using that kind of information to optimize their leasing fleet, right? Not only in terms of getting some predictive or preventive maintenance information from the cars, but actually varying leasing rates along the way, because depending on how much you drive, the value of the car kind of varies, and as a result, the leasing rate should vary. At the moment, not the case. At the moment, the leasing rate is flat, right? So that's going to change. Another example out of the manufacturing environment. As I mentioned before many times, that is for us very relevant. We are operating 250 plants around the world. And anything what could make this environment more productive, more efficient is of course of great interest. A part of the fact also that the things which we are producing could actually be a lot more intelligent, as a result provide new opportunities actually to create revenue streams. And that is what you see on that slide here, where we have done that already. Rexroth is a subsidiary of Bosch. You might know them if you know a little bit about the Marina Barrage project, for example, here in Singapore. All the hydraulics moving these large gates up and down to prevent the water from coming in, they're actually from Bosch Rexroth, right? They're producing large-scale machinery, hydraulics, all kinds of things going into various machinery. And for them, we have actually integrated, first of all, machine information coming directly from the machinery, as well as integrated with a lot of other systems like ERP systems, for example, spare part order systems, incident management systems, so that basically a new service has been created, which allows users, which allows owners of the machinery actually to access information much better and to also more seamlessly actually operate the machinery, there with increasing what we call OEE. And that is a measure of how efficient a factory runs, essentially, right? So one real-life example in the manufacturing space. Let's move to energy. Energy, as we had seen before, one of the megatrends, in order to actually avoid that the whole world is aspiring to actually consume energy, as in some developed countries, and just take into account Beijing at the moment. Every person in Beijing consumes about 1/4 to 1/5 of the energy a user in New York consumes, right? We certainly don't want to have everybody catching up with that necessarily, right? So energy efficiency and the way how we operate energy networks becomes a lot more important. And as a result, we are developing systems also using the same IoT platforms to actually connect various power generation devices. In this context, for example, in a virtual power plant concept, and that contains traditional power generation resources, traditional power plants, as well as renewable power plants and CHPs, combined heat and power plants, all of them together to actually optimize the way how they are being used at any given moment in comparison to the demand which is being provided by the consumers out there in their homes, right? That is called a virtual power plant kind of application, which is currently being rolled out. It is active here in Reutlingen, which is a small town in Germany. It's currently being rolled out on a nationwide basis by a renewable service provider in Germany and by another one in Scandinavia, actually, also. So one example out of the energy industry. Let's come to one last example, more comprehensively. And that is something I found very interesting looking at Santander this morning. We're doing something very similar in Monaco, where on one side we have certain applications, IoT applications running there, which are looking at crowd management, for example. Crowd management is an important thing in Monaco. Reason being, you might know Monaco is a very small space. It's 2 square kilometers only, right? The core of Monaco. It's connected through various escalators, lifts, and everything else. And in the morning, at certain times of the day, there's a huge amount of congestion actually happening. So people are going through all these narrow paths actually in the city to get from point A to point B. Crowd management becoming incredibly important. So all the cameras which are existing around the city, plus additional ones, have been now connected, will be connected into one system, which actually will allow not only to monitor, so to say, but to automatically glean metadata from there, which then actively allows to manage these crowds actually, right? Another aspect of that is fleet management, very similar actually in a way, because one key problem in Monaco was garbage trucks. Now you might wonder why garbage trucks. Now the streets of Monaco are very, very narrow actually. If a garbage truck is driving through one of them, you actually have a blockage, which might last 30 to 40 minutes actually in the worst case. So people are trying to avoid these things like we avoid mosquitoes or so, right? You try to avoid them at any cost, actually go around them at whatever, in order to not get stuck behind them. So what we have done, together with the authorities in Monaco, is in a first step now, all of these are connected. They're all exposed to the citizens of Monaco, and their routing mechanisms actually, in order to avoid that you get stuck behind one of these. The next step is now similarly, as we had heard this morning, to also measure automatically via sensors the fill level in the garbage bins and to reroute the garbage trucks accordingly. What is more interesting though maybe still is on the right side what we termed, or what Monaco termed, Monaco 3.0, a mobility app through which the citizens of Monaco, a citizen app, can interact comprehensively with the government of Monaco actually. So any kind of information which might be relevant, for example, that a certain street is dirty, that something doesn't work, etc., they can feed back through that. They, via this app, also get streamed all this information I just mentioned before, and they have one single point of contact where they can go and interact with their government actually. A real citizen app actually. Very fascinating. And what is the backbone of that is essentially the brain, the smart brain, I think the mayor of Santander called it this morning. Very apt description. It's basically a platform which we have installed there, which provides on one side device management, the M2M component, so to say, and the logic on top of that, the abstraction, because ultimately you don't want to have to integrate every time separately with any of these devices. You want to abstract, let's say, a washing machine or a solar power plant to a level where you can interact with any of them ultimately, right? And where it becomes like a printer driver which you install. When you install a new printer at your home, you just install a little printer and then it works actually, right? That is how it should be. That is how it should be for any device actually, being connected into the IoT, right? So that is what we achieve with the device abstraction, that we describe a device on a higher level actually, right? And then we have various modules on top of that which allow us to analyze actually the information, to crystallize events out of there, to drive software-based decisions, what needs to happen if that event arrives. And then as a fourth point, the process behind which then needs to happen, right? You have decided what you want to do, then now we need to do it, and that needs to be driven fully automatically by these platforms also. These platforms can then use, as very aptly said this morning, to drive applications across many different areas in a city, for example, right? Not only security, where the police force has access to certain cameras, for example. That should not be, right? These cameras which are around the city here in Singapore, thousands of them, they should be able to actually extract information for any of the authorities, actually, and to deliver certain metadata, which might be relevant also to, let's say, the NEA instead of the police only, because there might be a flooding on the AYE. That metadata should flow seamlessly from A to B. And that is what this allows, actually, ultimately. And then, of course, on top of that, the exposure to the various user environments, right? It provides a lot of support for this and that. I don't want to go into details. But that is essentially a couple of examples I wanted to share with you today to show you what can be done. Importantly, from our point of view, IoT, these are the key success factors. Ecosystem, again, we will not be able to do this on our own. We are working in consortia in many, many different groupings. Like, for example, we announced a couple of months ago a consortium for the smart home together with ABB, Cisco, and LG, where we are working together to define standards and common platforms for the smart home to allow applications coming from anybody to reside and work across different environments, right? Second, business model innovation. Most of these things will require new business models. We see that already. It was described earlier. We are also doing that already. Our packaging machinery is not being sold up front anymore. It's being sold by the number of pills which are basically packaged, right? Blister packaging machines. That is how it works these days. Already is happening, actually, right? And then on the right side, very important, also for a big company like Bosch, we need to be as flexible and agile as possible. The Internet of Things will change many things. It will change the way how we have produced our things in the last 127 years. And we need to actually find approaches to leverage off that. That is why Bosch Software Innovations was established as a separate entity outside of the frame of Bosch, actually, as a startup, if you want to, in order to take advantage of that kind of change and that kind of agility which needs to happen in order to make this a reality. Thank you so much.